For chemistry 2, SK025, again, how is the assessment? The assessment will be 40% exam. Okay, minus chapter 4. Okay, chapter 4 is not included in your exam. Okay, and then 20% UPS. Again, your UPS, we have UPS 1, UPS 2, and UPS 3. Same as your semester 1. It's just that when we are nearing the UPS, then I will share to you the poster for the UPS as well as the revision question. Okay, and then we do have 40% PB. PB means that it is penilaian berterusan or continuous assessment. Okay, so for the continuous assessment, it consists of 15% of our assignment. So assignment is our chapter 4. So the chapter that is assessed during your assignment, it will not be assessed during your exam. Okay. And then 10% lab skill and 15% lab report. Okay, if kalaulah kita boleh, nanti tak tahulah macam mana nanti kan. Kalau lab skill is face to face, dan kalau our lab test is during face to face punya session, macam mana yang akan buat is actually you gonna do the experiment by yourself, and then lecturer mostly me lah akan assess how do you do during your experiment itself. Tapi if your lab test is online, what you have to do is actually sama macam SEM 1, you have to answer the Google form. Okay? And 15% lab report. So lab report ni sama sahajalah. Memang you have to start, you have to write it down from the start, from your, what do you call that? From your introduction until your conclusion. Okay, but then for semester 2, the chapter is quite a lot. We have 13 chapter. Chapter 1 until chapter 13. Okay, so we have finished chapter 1. Okay, for tomorrow class, we will have chapter 2 and chapter 3. And then chapter 4 is introduction to organic chemistry. Okay, actually for your semester 2, chapter 1 to 3 ni, we're gonna do lots of calculation lah. Ini masih lagi macam apa yang kita rasa chapter 1 punya, semester 1 punya chemistry, where kita akan do calculation, ada juga explanation, but mostly it is calculation. Tapi start from chapter 4, introduction to organic chemistry. Okay, so siapa yang PDT dah belajar lah kan waktu semester 2 kamu dulu, SEM 2 kamu apa, DK024 so introduction to organic chemistry, and then chapter 5 until chapter 10, chapter 13 ni semua kita akan belajar organik. So contohnya kita belajar hydrocarbon, apa lagi kita belajar, benzene, haloalkane, amino acid, polymer. So memang untuk semester tu ni memang banyak sikit chapter, especially yang ni lah, starting sebab organic chemistry ni. Okay, so that's it for your yang briefing tu. Apa nak cakap tadi? Pasal yang exam ni, we do not know. Memang 40% exam kan, but we do not know whether objektif ke subjektif. Yang tu tak tahu lagi. But surely it will be it will be face to face. Objective or not sure. Okay, so that is for chemistry 2 SK025. Okay, next is actually calendar academic. Calendar academic ni, so yang ini I haven't uploaded in your Google Classroom yet, tapi nanti Miss akan upload. Okay, so from here kita tengok sebenarnya we start our week 1 from ingat tak yang hari tu yang last minute kita tahu kita punya kelas kita start lambat seminggu kan. Tapi sebenarnya that week sebenarnya kita akan ganti. Tapi week 1 will be replaced on Saturday. So wait for further notice. So sebenarnya kita ada 6 jam kan. Every week kita memang dapat 6 jam. Okay, nanti kita akan gantikan lah on Saturday. Which Saturday it will be it will be noticed later. Do not know. Sepatutnya one of the week is last Saturday, tapi dah last minute kan. So tak ada. Okay, so actually even though it seems like this is baru second week kita kan. Last week baru masuk kelas semua, tapi calendar akademik minggu ni dah start minggu 3 dah. Okay, lepas tu kalau kamu tengok kan memang for each week mostly memang one week one chapter. Adalah serta chapter 5 panjang sikit, Chapter 8, 9 pun panjang sikit. But mostly kita akan tengok every week we have new chapter. So janganlah kamu terkejut if after this yang macam cepatnya dah start new chapter. Especially nanti bila organic memang akan laju. And especially yang ni okay, week 1 ni akan replace later kan. Lepas tu yang week 5 ni 31 Januari sampai 4 Februari ni kita ada Isnin 31 hari bulan, Selasa 1 hari bulan 2, Rabu 2 hari bulan 2, Khamis 3 hari bulan 2 kan. Okay, so all of this is actually our public holiday. So kiranya minggu ni pun kita macam burn. Tak ada kelas juga. Week ni pun tak ada juga. So lagilah macam mana minggu tu pergi. So memang lepas ni memang rasa macam every week new chapter lah. Okay, yang ini okay, kalau kamu tengok pula based on practical session, experiment started from week 6. But week 6 ni rasanya kita akan ada start face to face lah. Okay, nanti week 6 and 18 tu the hybrid sebab ada certain hour will be online, certain hour kita akan face to face. So tutorial kita akan dapat 2 jam, 2 hours face to face dengan lab 2 hours as well lah untuk lab. So total kita ada 4 hours kita akan face to face, 2 hours ni online. Yang 4 hours face to face ni memang kita akan tengok akan memang asing ikut kelas lah. Okay, so from here kamu tengok kamu ada eksperimen tu. Lepas tu bila kamu start dengan eksperimen tu, terus start dengan lab test. So kan senang nampak tahu which one yang jadi lab test kan. Lepas tu nanti barulah kita start dengan eksperimen, the other eksperimen. So ada sampai 6 eksperimen. So here, subject to change. So, kat sini just nak bagi tahu pasal eksperimen, ada juga tanda-tanda UPS. Okay, lepas tu jangan terkejut. Kalau lepas ni memang every week new chapter. Kadang maybe boleh 1 week 2 chapter pun. Okay, so that is actually for our introduction sahaja. Okay, next barulah kita akan start buat past year. Past year question sikit je Miss nak discuss. Hopefully by 1 hour je. Okay. So let's look for question for UPS 2015-16. Okay, yang ini kita akan buat sama-sama. Ada satu soalan yang Miss akan bagi masa untuk kamu jawab lah. Tapi mostly kita akan jawab sama-sama. Okay, so let's do it together here. UPS 2015-16. Okay, so here it mentioned that table 1 shows the data obtained from the following isomerism reaction. So ada from A becomes B. So from question 1, they ask you determine the order of the reaction. Okay, so how to determine the order of the reaction? Okay, yang ini kita belajar awal-awal dekat 1.1. 1.1 kita belajar banyak formula kan. But before that, at the start, we do learn about our initial rate method. Okay. So how are we going to do this? Determine the order of reaction. First and foremost, we have to write down the rate law. So kat sini kita tulislah rate law. Our rate law for this experiment is actually rate is equal to X. Okay, where we do not know. X ni is what? What is the order of the reaction? Okay, again, rate law is equal to rate constant and the concentration of reactant. In this case, reactant kita is A and raised to some power. Okay, raised to some power ni, it actually here, we have our X ni lah. We do not know the order first. So how to determine? From here, we only have information tentang experiment 2 and experiment 1. So what should we do next is actually we're going to find out our our order. So by dividing experiment 2 divide by experiment 1. Okay, so here experiment 2 divide by experiment 1. So what we're going to do is actually we're going to substitute all of this value into our rate law. So contohnya experiment 2 1.2 exponent -5 divide by experiment 1, what do we have is actually 3 exponent -5 equal to K 0.25 X. Okay. So from here, yang ini kita boleh nampak straightforward lah. So 12 divided by 3, so we do get 4. So 4 is equal to 2x. Okay, sebab yang ini we cancel out lah. K dengan K ni we do not know the value yet. So from here we know that it's actually 2 to the power of 2 equal to 2x. So x is equal to 2. So from here we can determine the order of reaction is actually 2. Reaction is 2. Okay, sebab that is the question kan. Okay, this question quite straightforward sebab reactant kita ada satu sahaja. Okay, there are certain example on your notes ada sampai 3 kan. Yang itu you just have to make sure kalau kita ada banyak reactant, bila nak cari the order again, kita akan using the same concentration lah. Okay, and then ada juga yang tanya waktu yang examples tu, memang ada certain order of reaction memang dapat 0.5. Okay, hanya untuk that question lah. Tapi for the further 1.1, what we have learned hanyalah zero order, first order dengan second order. Tapi ada example tu memang kita akan dapat order of reaction is 0.5. Okay, so that is actually for question number 1. Okay, so number 2, they ask you calculate the rate constant for this reaction. So macam mana nak calculate the rate constant? So kita tahu from here our rate law is actually rate is equal to Ka to the power of 2. So kita substitute sahaja. So either one pun boleh. It's either experiment 1 or experiment 2. So I'm just going to use the experiment 1. So experiment 1, read the 3 exponent negative 5 equal to K. Concentration of A is 0.25. The power of 2, hence I will get my K to be from here 4.8 exponent negative 4. Okay, dekat sini yang tricky bit dia. How about the unit? Okay, kat sini memanglah kita macam tengok je lah sini. In exam, the unit is not given to you. So you have to write down lah. Tak tahulah walaupun tak tahu exam kita objektif ke tidak. But then we have to do lah. What is the step? Okay. Senangnya kalau Miss suka buat sebab tak perlu nak hafal, kita buat macam substitution tu lah kan. So rate kita tahu, rate unit dia adalah mole per liter per minute ataupun I'm gonna write down capital M. Rate equal to Kn to the power of 2 ni. Rate ni unit dia M per minute. Mole per liter ni the same as capital M. Okay, molar per minute equal to K. Concentration unit dia is always molar or mole per liter. But I like to write down as capital M. So here the unit will be M squared. So from here I know that my K will be M per minute divided by M squared, which is equal to molar negative 1 per minute, per molar per minute. Because we have cancel out yang squared ni kan. Dah cancel out yang jadi 1, yang ini kita cancel out terus. So dia jadilah per molar per minute. So here we get the unit to be per molar per minute. So this is question 2. Okay, determine the value of X. So kita akan substitute sahaja dalam rate law kita terus. So question number 3. Okay, we know that rate is equal to Ke squared, where in this case our rate is our unknown, that is our Z. Okay, equal to K. K is the one that we have found out from previous question. 4.8 exponent negative 4. So dekat sini 4.8 exponent negative 4. Okay, and then the concentration of A is 1. So here we know it is 1 squared. Hence we know that Z is equal to 4.8 exponent negative 4. Again, this Z is actually our rate. So tengoklah dekat sini unit dia. If you don't want to write capital M, unit dia pun boleh juga kamu tulis sahaja mol per liter per minute. Okay, so that is actually for question number 3. So yang ini straightforward, kita substitute saja. Example, ada example 6 rasanya nota kamu tu. Sekejap kita tengok balik nota kita. H6 example 6. So untuk yang example 6 ni mesti ramai je dapat jawab. So memang before you're going to find out your V, W, X, sebenarnya kena cari dulu your K first. So then once you find your K, barulah kita boleh substitute to get V, W and our X. Okay, so that is for question UPS 2015-16 question 1. Next question, what we're going to look at is actually question B. Okay, so here it mentioned that the following reaction has an activation energy of 120 kilojoule and delta H is equal to 113 kilojoule. Okay, so first foremost, they ask you to define activation energy. So here is basically from your 1.2. Okay, 1.2 kamu lah. Okay. First, to define activation energy, this one is actually betul-betul miscopy from our notes itself. Activation energy is the minimum energy required for the molecule to start the chemical reaction. Okay, so that is for question 1. Okay, question number 2. Okay, they ask you to draw and label the energy profile diagram for the above reaction. Okay, so for energy profile diagram, we have learned about our endothermic and exothermic. Okay, this one actually can be found in your notes. Kita tengok balik. Okay, on your page 18. Okay, so we have learned about our endothermic and exothermic. And actually dalam Google Form yang Miss bagi pun banyak juga Miss tanya pasal endo dengan exothermic. Okay, so how to know whether it's endothermic or exothermic? We have to look at your delta H. For exothermic, delta H is equal to negative. Kalau endothermic, your delta H is equal to positive. Okay, so for this, what we're going to do next is actually, kita tengok balik tadi question tadi, what is my delta H? Okay. My delta H is positive 113. So it means that this reaction is an endothermic reaction. Okay, so what should we do? Okay, for the first step untuk draw energy profile diagram, first one kita kena buatlah our y and x axis. So kita buatlah kita punya y axis dengan kita punya x axis, and then we have to label our y axis and x axis. Okay, y axis is your potential energy, and your x-axis is your reaction progress. Okay, so that's the first step. Okay, next is actually we're gonna do the shape. Okay, macam mana nak tahu the shape dia kan? Dia macam nampak macam bukit tapi macam ni Ataupun boleh jadi yang ini, ataupun tik. Okay, that is the shape. Okay, so how to know the reaction? So, okay, for endothermic reaction, it means that heat is absorbed. Sini gonna write down. Yeah. Heat absorbed from surrounding. So bila heat absorbed from surrounding, so maknanya kalau untuk kita punya reactant, okay, for example reactant kita originally, contohnya lah I'm just gonna give any value. Contohnya dia punya energy at first is 80 kilojoule per mole. But once the heat is absorbed, our potential energy kita will be higher lah kan. We do not know the value. Yang ni Miss just bagi je lah. Okay. So, from here, we know that the energy of our reactant is lower than the product. Sebab bila heat dah absorb, product tu dia lagi panas lah. Potential energy is higher. Okay, so what should we do? So, maknanya daripada sini, kita akan nampak that our reactant kat sini dia akan lagi rendah potential energy. Tak perlu state the value pun. Okay, tapi we know that potential energy of the product is higher. So, kita buatlah ni. Okay, next what we're gonna do is actually kita akan buatlah bukit kita. So buatlah bukit. Tada. Okay. Saya ingat sikit tapi yang Okay. So, after we have done the shape, what should we label? Labelkanlah reactant dengan produk. Dalam kes ni, reactant kita 2NO2, produk kita 2NO plus O2. So, here 2NO2, here is 2NO plus O2. Okay, besides that, what we have to label is actually our transition state. Okay, this is my transition state. Okay, so dah labelkan ni, what should we label next is actually kita punya activation energy forward, activation energy reverse dengan kita punya delta H. Okay, so what we have learned from 1.2, kita tahu reactant ni okay, akan undergo transition state first, baru akan form kita punya produk. So, from here, from the reactant to transition state is actually kita punya activation energy forward, while the product to transition state is activation energy reverse. Okay. So, what should we do next? Okay, first reactant to transition state. So, reactant to transition state, here is our EA forward. So, here is our reverse is actually from product to transition state. Okay, so here is actually activation energy reverse. And last but not least, what should we label is actually our delta H itself. So delta H itself is actually between our product and our reactant. So delta H, I'm just going to write down kat sini. Delta H is actually product to our reactant. So here, product reactant kita is this one. So here is my delta H. So let me draw this. Okay, so that is for your activation energy. That is for your energy profile diagram. Okay. So for energy profile diagram, dia memang banyak step dia lah. But then you should be able to draw it. Memang kita kena tahulah how to draw. But first and foremost, tengok dulu what is your delta H. Is it endothermic or exothermic reaction? Okay. Okay, next one, they ask you to determine the activation energy for the reverse reaction. Okay. So, activation energy for the reverse reaction, yang ini pun mesti ingat dia punya calculation macam ni. Tengok balik nota tadi. Okay. Delta H is actually activation energy forward minus activation energy reverse. Okay, so kita tengok sini. Just gonna write down kat tepi ni. 3. Okay. So we know that this is the formula. Delta H is EA forward minus EA reverse. Delta H is given in the exam, in the question is equal to 113 equal to activation energy forward. Okay, in this case, they ask you to determine activation energy reverse. So for the reverse here, this is our unknown lah. So it means that activation energy forward is given in the question. So which one is the activation energy? Here, it's actually 120 here. So the question 120. So carilah kita punya EA reverse. Okay. So from here we know that kalau kat sini kita tengok straight away negative 7 equal to negative EA reverse. Okay. Tapi we want it to be activation energy reverse sahaja kan. So we cancel out lah negative sign. So dapatlah positive 7. And the activation energy unit dia adalah kilojoule. So this is actually for question B. 2015-16. Okay. Next question. Kita akan buat 2 tahun punya soalan je. Okay. Next question what we're going to look at is question for 2000. Dah kita tengok 15-16 kan? Yang 14-15. 14-15. Okay. Okay. Lepas tu untuk past year memang Miss tak includekan soalan PSPM pun tau. Sebab data soalan UPS pun dah susah jugalah untuk Miss. Lagipun nanti banyak latihan nanti Miss akan bagi. Jangan risau. Nanti at the end of tu nanti kita banyak lagi. Lagipun sebab tak tahu kan nanti objektif ke tidak. Kan senang kau tahu awal-awal. So that nanti bolehlah senang cari soalan. Okay, tak apalah. Sekian bibilan hari ni. Okay, so let's look for question 2014-15. Okay, so from here, they give you the differential rate equation. So this is differential rate equation. Okay, so differential rate equation given below. Write a balanced equation for the reaction. Okay, so selalunya dia bagi equation dekat kamu. Lepas tu kita write down rate law kan? Rate law pula. Differential rate equation. Write down, they give you the differential rate equation. So you have to find out the balanced equation. Okay. So let's look here. It started with negative 1 over 2 d N2O5. So we know that this is the species for reactant since it is a negative. So kita write down the answer. So maknanya dia jadi N2O5. So this is my reactant lah. Lepas tu, here we have 2, 1 over 2. So it means that this equation is 2. Okay. And then, the next species is actually we do not have negative ataupun positive. Negative or positive sign. Tapi we understood from here maksudnya ini adalah positive sign lah. Okay, so here is my product. NO2. So NO2. Okay, so when we look here, dia adalah 1 over 4. So dekat sini 4NO2. And then this is for the product as well. But we do not have any coefficient ataupun we do not have any fraction kan. So maknanya sini dia 1 over 1 lah. So plus O2. So that is the equation. So this is actually the differential rate equation. Differential rate ni, differential rate dia over dt lah. Kalau contohnya dari sini, kalau kita nak write down rate law, okay, this is differential rate equation. Kalau rate law pula macam ni. Kalau rate law, based on this equation, kita tahu rate law is equal to rate constant times the concentration of the reactant raised to some power. Power tu is order of the reaction lah, which we cannot be determined from the equation itself. Ini kita kena cari lah. Okay. So that is for the question. So again, dia different tau. Differential rate equation dengan rate law is a different thing. Okay, ni label lah. Ni adalah our rate law. Okay, so that is for question 1A. Question 1B. Okay, so here it mentioned that given rate is equal to this one. Okay, what factor does the rate increase if each of the following changes occur? Okay, so sebenarnya yang ini kita ada tengok very briefly during your apa nama ni? Introduction to the order of the reaction. Kita tengok balik kat nota jap. The effect of increasing your concentration of reactant. So kalau kita tengok zero order, does not have any effect. Kalau apa ni nama dia? First order increase by a factor of 2. Okay. Kalau second order increase the reaction by a factor of 4. Okay. Tapi yang tadi tu dia macam gabungkan ada 2 different order of reaction. Lepas tu dia suruh triple lah, ada yang double lah. Okay. So what we're going to do, sama juga macam ni, Miss akan assume the first concentration is 1 molar. Second concentration apa yang dia bagilah. Okay. So how do we answer it? Okay, so first one, what I'm going to write down is actually here. So from here, we know that rate law is equal to K NO2 to the power of 2 Cl2. Okay, but then from the from here, dia mintakan what factor does the rate increase if triple. Okay, so sebelum dia triple ni, kita akan assume that the concentration for the rate 1, kita akan assume the concentration of NO2 is 1 molar and concentration of Cl2 is 1 molar. Okay. So, dekat sini, what I'm going to do is actually, Miss akan substitute the values here. So, here, remember kita label lah rate 1. So, concentration dekat sini akan jadi 1. Concentration sini pun akan jadi 1. Okay. So rate 1 kita akan jadi K lah. Okay, kalau masih tak nampak lagi tak apa. So sekarang ni kita tengok sebab based on question dia minta What if the concentration of NO2 is triple? So from here, Miss Suris read 2 pula is when the concentration of NO2 triple. So dia triple jadilah 3 molar. Okay. But what happened to the concentration of Cl2? Okay, for Cl2, concentration dia is the same, remain the same. So Cl2 is equal to 1 molar. Okay, so from here, what should we write down next? Okay, so kalau rate tu, kita akan dapat K and then concentration of NO2 sekarang ni bukan lagi 1 molar sebab the question wants the concentration of NO2 to be triple. So write down lah 3 molar here. 3. Don't forget to the power of 2 sebab the order of reaction here kan. Okay, and then concentration of Cl2 is still the same. So the power of 1 lah. So from here, we know that the rate 2 is equal to, so maknanya when we multiply this, we do get 9K. Okay, so when we compare the reaction, okay, at the start, when the concentration kita assume dia 1 molar, rate dia K sahaja. But then once we change the concentration, since the question asks to change the concentration of NO2 to be 3 molar, so dekat sinilah kita akan tukarkan NO2 jadi 3, Cl2, but dia tak ada mention kan kena ubah apa-apa, so we're going to take it as 1 sahaja. Okay, so sekarang ni kita tengok the rate is 9K. So the rate increases from K to 9K. Sebenarnya concentration ni kamu boleh je lah buat nak 2 and the value pun boleh. Tapi macam straightforward lagi, first kita assume 1 saja. So that nanti dekat sini, kita boleh tengok senang. And when we comparing these 2 value pun jadi straightforward sahaja. Okay, so maknanya dekat sini, the question asks, by what factor does the rate increase? So from here, we know that the reaction increase by a factor of 9. Sebab kat sini 9. So instead of K, dia jadi 9K. Assume sahaja at the start of the experiment, concentration dia 1. Okay, and then second one nanti, tukarlah mana yang dia suruh. Lepas tu kita change. Okay, so for question 2, you could try yourself. Question number 2 ni, okay, so yang ini Miss buat dekat poll. Okay, so Miss dah letak dah dekat poll tu, so you could try yourself first. Tengok dekat question ni apa yang berubah. So tengoklah jawapan dia. Okay, Chiang ada tanya, if the question asks about pressure, if half or double, will affect the rate of reaction. Actually the pressure does affect the rate of reaction kan. Kita belajar yang 1.3 tu ada pressure lah, temperature lah semua tu kan. But then I think it will affect the rate of reaction as well. Kita akan assume je lah macam pressure tu the same as our concentration. So kita akan assume macam tu. Tapi Mrs. pun pernah jumpa juga soalan kan. So what should you do is actually memang kita buat je how do we do our rate law yang ni. Maksudnya instead of concentration, kita buat yang the pressure dia lah. Mesti dia nak tanya pressure increase by what factor. Tapi kalau question tanya does not change, ni pula. I think it does affect the rate of reaction. Dia akan change. Okay. So kita tengok balik tadi, poll tadi, lupa pula tengok Okay. So ada yang vote juga factor of 2, ada 4, ada 6. Okay, so kita tengok what is the answer. So kita tengok answer dia. Okay, jawapan dia is actually D, a factor of it. Okay, so sebab dia 2 to the power of 2 dekat sini. Lepas tu sini pun 2. Kalau Miss rasa yang jawab a factor of 4 tu maybe lupa nak include ataupun maybe lupa nak includekan this one. Ataupun kalau 6 tu maybe campur dua-dua. Okay, so that is actually for question number 2. Okay, ada satu Miss bagi soalan extra sikit. The same rate law, which is rate law dia, Miss tulis kat sini lah. Rate law is equal to tadi K NO2 dengan NO2 to the power of 2. Tak nampak pula to the power of 2 and Cl2 to the power of 1. Tak adalah. Okay, so yang ini pun again, try yourself, kita buat lagi satu. Tadi ni punya label rupanya mute. Okay. Sekejap. Okay. So betul lah. Tadi Aziza dah cakap concentration NO2 double dengan yang tu triple. So we do get 12K. Okay, so for this reaction, apa ni, sampai sini sajalah Miss akan tanya. Okay, walaupun soalan nampak simple, tapi kalau tak ditunjuk pun pening juga kan. Okay, so next what we're going to look at is actually question, masih lagi the same year, 2014-15, question C. Okay, memang hari ni kita nak discuss 15-16 or 14-15 sahaja. Okay, so this is actually based upon our integrated rate equation. Okay, so for the integrated rate equation, memang nak tak nak, you have to memorize the formula. Okay, so kita tengok dekat sini, compound X decomposed according to the equation. Okay, so here is our equation itself, and then ask you, it was found that 50% of X had decomposed after 100 minutes. How much of X will remain after 150 minutes if the reaction is first order? Okay, so for chapter 1 ni, memang kalau kamu tak hafal formula, memang tak dapatlah nak jawab. Okay, so this is actually all the formula that you have to remember from your, apa nama ni? First order. First is your integrated rate equation. Okay, the blue one is your half-life. And the last one is the unit of K, the unit of rate constant. Because some of the question itself, yang ada example, so example on your notes, it does not give it to you macam straight away the first order ke tidak. Sometimes it give you the K. Then you have to determine what is the order of the reaction. Because kalau dia zero order, unit of K dia molar per time. Kalau first order, per time. Kalau second order, per molar per time. Time tu tengoklah what time yang is given to you. Okay, so kita tengok dekat sini. Okay, so here dia bagi tahu how much of X will remain after 150 minutes. So, dekat sini, they ask you what is, okay, time dia 150 minit. Okay, tapi what is the, how much of X will remain? Maknanya concentration of X tu berapa? Okay, so kalau kita guna straight away, maknanya yang sini sebab, again, kat sini A ni sebab waktu Miss introduce tu, my reactant is A. But if the reactant, if the question give you the equation, kita kena ambil from the equation lah. Ln X naught minus X T equal to KT. Okay. Okay, this is the one that we have to find out. Okay, tapi, so maknanya T ni dekat sini, ln, X ni is our unknown. Okay, naught ni jadi berapa? Naught ni sebab kita nampak 50% kan. So maknanya our originally, so from here we can conclude that our original concentration A pula. Ini pun tersilap. X naught ni is actually 100 lah. 100% ataupun 100. So kita boleh assume tu. Okay, yang ini masuk sini. Ni masuk sini. This is our unknown. Okay, tapi K kita tak tahu lagi. Okay, so what should we do? Sebenarnya kita kenalah find K first. So first, find K. Lepas tu barulah kita boleh guna equation ni to find out yang this one. Okay, how to find out K? Dia kata dekat sini, it was found that 50% of X has decomposed after 100 minutes. Okay, so this is the information that kita ada daripada sini kan. Okay, so from here, kita bolehlah guna the same formula. Okay, tapi kali ni kita punya information that we have it's actually, okay, kita punya X naught dia akan jadi 100. Tapi kita punya X current jadi 50 lah. 50. Okay, kenapa 50? Sebab dia dah decrease by 50%. So what is left is 50 juga. Okay, kat sini time dia is actually 100 minute. So dekat sini kita boleh substitute. So dia jadi, here it become 100. Here dia jadi 50. T dia adalah 100. Okay. So from here we will get our K. So how much is your K? Sekejap nak tengok ke. So when you calculate it, okay, check juga dapat tak? Actually the answer will be 6.93 exponent negative 3. Let's check balik betul tak? Okay, exponent negative 3. But don't forget what is the unit. Remember, unit for first order is per time. In this case, our time given is minute. So dia jadi per minute. Okay. So, when we find out our key, barulah kita boleh cari yang ni lah. When time is 150, what is the concentration? Okay. Tapi sebenarnya dekat sini ada lagi satu tips. Dia bagi tahu dekat sini kan, 50% of X has decomposed. So maknanya concentration tu decrease to half. So sebenarnya this one is actually our half-life. Okay, kenapa dia half-life? Sebab concentration tu decrease by half kan? So dia half-life lah, T half. So kita pun boleh cari juga, dia adalah half-life is equal to ln 2 over K. So kalau sini 100, sini ln 2 divide by K. K kita pun akan dapat 6.93 exponent negative 3 per minute. Okay. So it's either way lah. Mana-mana kalau kamu tak nampak this is half-life, boleh je cari yang ini. Still you will get the same answer. Okay, so from here, once we found out your K, barulah kita boleh cari how much of X will remain if after 150 minit. Okay, so yang ini masukkan. Kalau untuk yang time dia, this is for when time is equal to 150 minit. Still, the concentration initial masih lagi 100. Okay, this is X. X 100. Lepas tu K tadi kita tahu from question 6193 exponent negative 3 per minute. Okay. So kita boleh substitute lah dalam soalan. So ln 100 minus ln xt is our unknown. Betul K kita 6.93 exponent negative 3 times 150. Okay, so dekat sini when we calculate it, kita akan dapat lah. Yang ini hopefully you get the answer lah, 35.4. Yang ini miss tak calculate lah. We get the concentration to be 35.4. Sebab dekat sini dia bagi tahu percentage kan. So kat sini sebab itulah kat sini kita buatlah percentage. Okay. That is for question C. Okay. So memang certain question they ask you memang kita kena buat 2 steps lah untuk find out the answer. So in the first one ni, kita kena cari dulu K kita. Then we can find out our concentration after 150 minutes. So that's for question C. So again, untuk integrated the equation, nak tak nak, you have to memorize the, what do you call that? The formula. Memang kalau 1.1, inilah yang ada 3 equation tu. Sebentar kejap. Okay, nanti tapi sebenarnya untuk 15, 16 ni ada lagi satu soalan lagi kita akan buat. Ini pasal Maxwell-Boltzmann. Lepas tu ada satu sikit je soalan yang kita akan tengok sama. Yang tu pun tak buat penuh pun. Okay, so that is the solution. Kita tengok next question. Yang ni yang Maxwell-Boltzmann distribution tu. For the question, so the same year, masih lagi 2014-15, it mentioned here the curve below shows the energy distribution for collision between chlorine and ozone at temperature ni. And EA represent the activation energy. Okay, so the question asks you to redraw the diagram and shade the area on the graph that represent the number of molecule with sufficient energy. Okay, maksud dia kita kena redraw the diagram balik. So kita redraw lah balik. So kalau Maxwell-Boltzmann dia memang tak adalah banyak minta kamu explain pun. It's just ask you to draw. Kita buat balik. Okay, so your y-axis is your number of molecules. Your x-axis is your kinetic energy. Okay, lepas tu apa lagi dia minta? Dia buat graph kan? Dia buat graph kat sini. Macam ni, buruk lah. Yalah. Okay. So from here, dia bagi tahu this is my EA. This is my EA lah. Okay. So here it mentioned that shade the area on the graph that represent the number of molecule with sufficient energy can lead to the formation of product. Okay, so that lead to the formation of product. So maknanya kita for the formation of product. So it means that mestilah dia undergo effective collision. Okay. The requirement for effective collision, satu adalah with correct orientation. Okay. The second one is that your energy must be, your energy ataupun your kinetic energy must be greater than or equal to your activation energy. Kan? Okay, so maknanya kalau kat sini kita nak the number of molecule with sufficient energy can lead to the formation of product. Again, here it means that effective collision lah. Effective collision. So effective collision, it must be when the energy is higher than kinetic energy. The kinetic energy is higher than activation energy. So which one? It's actually here. Yang more higher than our activation energy dekat sini lah. Okay. So that is your question number 1. Dia macam nampak macam susah je Maxwell-Boltzmann tu, tapi dia quite straightforward. Okay, next question. On your graph, sketch a curve that represent energy distribution for the collision if the temperature is increased by 10 Kelvin. Okay, yang ni sebenarnya lupa pula. Ni tadi T1 kan? Okay, so sekarang ni kita kena draw T2. Okay, tapi right now T2 ni kena increase by 10 Kelvin. So maknanya a higher temperature. Okay, so what happens is that kalau higher temperature, bentuk dia akan jadi macam lagi flat lagi. Dia macam akan jadi bukit yang cantik lah. Dia punya distribution tu. Okay, so what should you do? Kalau T2 maksud dia concentration is higher kan? So kita buatlah macam ni. Macam ni. Nampak tak colour ni? Alamak. I'm just gonna change it to different colour je. This is my T2. Okay, tak perlu pun nak kata dia increase by what, tapi kita tahu kat situ lah. Okay. Lepas tu, itu sahaja dia minta. Dia tak ada minta shade ke apa benda kan. Okay. Next, from here dia kata give a conclusion based on the curve sketch. So sebenarnya, bila kita tengok dekat sini, kan, kalau kita compare the blue one, ni kalau Miss buat lah, for example, kita buat contohnya nak guna colour merah ni lah. Okay, so contohnya if I sketch my molecule which is greater than my activation energy. Contohnya Miss sketch lah kat sini kan. So we can see that the number of molecule is higher kalau compare to yang kalau temperature kita ni is low. Okay, So, what should we write down for the conclusion? Okay, so for the conclusion, kita just bagi tahu at T tu, mana tadi? Ni, for question number 2, okay, kita bagi tahu at T tu, maknanya more molecules, okay, have kinetic energy. Sebenarnya kita nampak dekat sini, kalau ni shade kan, nampak ada lagi banyak lagi. Daripada kalau originally yang P ni sikit ni je. More molecules have kinetic energy higher than activation energy. Okay. Itu sahaja for question 2. So, contohnya, kalau ni adalah T2 lah, kita increasekan by 10K. Contohnya kalau kita increase lagi concentration, yang ini misal tunjuk lah macam ni je. Kalau kita increase lagi, so maknanya dia akan jadi lagi flat lagi. Dia jadi flat lagi kan macam ni kan. So bila kita nampak ni lagi lah banyak molecules yang have kinetic energy higher than activation energy. Dia kalau low, dia macam jadi lagi dekat kat sini lah. Itu sahaja untuk question number. Okay, so for your Maxwell Boltzmann tu, kamu kena faham yang the one that lead to the formation of product, maknanya dekat sini je lah. Dia nak tunjuk dekat kamu number of molecule tu banyak mana. Dia suruh kamu shape the number of molecule that leads to the formation. Okay. Okay, last but not least, kita akan tengok the last one. Yang ini tak ada misal buat dalam kerja pun. Just nak ingatkan kamu, okay, ada satu soalan, okay, ada dua soalan kat UPS ni. Okay. Nampak? Okay. So here, dia bagi dekat yang UPS 2012 and 13. Dia bagi tahu figure 2 shows the graph for the composition of N2O5. Okay, next question, they ask you to determine the order of the reaction. Okay, so from here, as we can see, it is actually a straight line graph. Okay, lepas tu, bila dia straight line graph, kita tengok y-axis is time, tapi x-axis dia adalah x-axis is time, y-axis is ln concentration of my N2O5. So from here, so kat sini dia buat ln kan, so maknanya kita tahu this fraction. Kita tengoklah balik pada integrated rate equation. Which one yang ada ln? Yang ada ln is actually our first order. So write down lah the order of reaction ni. Dekat sini is actually here. First order. Okay. Again, this is actually based on your linear graph method. So linear graph method, yang ini. Tengok balik. Yang this one. Linear graph method dekat sini. Tada! Pak ln kan? Okay, nasib dia tak bagi kamu concentration against time. Concentration against time nanti kena carilah your half-life method. Okay, this one is important memang untuk half-life ni sebab last year yang batch lepas 2000, kamunya batch kiranya 21-22 kan? Batch 2021, memang soalan past year dia bagi kamu graph kan, macam dia bagi graph tak ingatlah yang mana, lepas tu dia minta kamu determine the order of reaction. Memang kamu kena carilah yang first half life, second half life, so that's why the graph is still important juga sebenarnya. Okay, that is for those question. Okay, so bila write the rate law, so kita boleh write down lah. Rate law is actually rate is equal to K N2O5 to the power of 1 for first order. So that is for question 2012-13. For yang turn 11 ni, yang ini sama juga. Dia bertanya dekat sini, the following equation shows the decomposition with a rate constant 5.09 exponent negative 4 per second. So they ask you to state the order of the reaction. Okay, so how do we know the order of the reaction? Based on our rate constant. So since it is per time here, ni kan kira per time kan, dia tak ada molar di hadapan ataupun per molar. Okay, so it means that this reaction is a first order. Okay, yang itu saja. Yang ini, question 2. Sketch a graph on the reaction rate versus the concentration. Okay, so from here, contohnya kalau Miss buat concentration against time. So ni time, ni concentration of SO2Cl2. Okay, so from the rate law, we know that rate is equal to K SO2Cl2. So since it is a first order, it's directly proportional. So kita buat macam ni lah. Ni saja. Tada. Okay, so actually graph ni pun kamu kena tahu juga. Okay. So that's it for this question. Yang ini sahaja, the last one. Lepas ni Miss ada, lepas ni tak ada apa-apa dah pun. Okay, it's just that for your notes, asalnya Miss bagi completed notes kan. This time around Miss tak bagi sebab nanti Miss fikir nanti buka cuti nanti kalau kita sempat face to face, bolehlah Miss check nota kamu. So nanti kalau Miss dah upload nanti macam main tipu pula kan. Tapi tengoklah dulu, kalau Miss rajin Miss akan try marking kerja semua orang. Or Miss akan compilekan notes. Notes tu Miss compile based upon your own PDF. Nanti Miss dah compile lah. Sesuatu yang terpilih, Miss akan tunjuk supaya kamu boleh check. Okay.